Biochemistry video number 2. Today's all about carbohydrates, which of course you know are sugars. So things about sugars. First of all, they have a really basic formula: carbons, hydrogens, and oxygens in a 1 to 2 to 1 ratio. So 1 carbon for 2 hydrogens for 1 oxygen. If you think of glucose, C6H12O6, you've got carbon, 6 of them, double it. 12 hydrogens and then 6 oxygens. Now as you get into larger ones like the disaccharides and polysaccharides, the numbers might not be perfectly 1 to 2 to 1, but it's really close. Every carbon gets its own oxygen. That's how you can notice it in a picture right away. Alright, what are they for? Carbs are for energy. If you have a really simple carb, it is an energy source. If it is energy storage, it's a larger molecule like pasta. You eat it the night before because it's a good storage source of energy. Their shape. You can have a carbohydrate in a chain, but usually it rings, which means it wraps around and forms this ring shape, and we classify them by the number of rings that they have. So I'm sure you remember monosaccharide, 1 ring, disaccharide, 2 rings, polysaccharide, many rings. Alright, what is a really important characteristic? The fact that they dissolve well in water. So you eat sugar and then you can distribute sugar through your body because it dissolves well in the blood. That's because oxygen is negative. It's very electronegative and it has a pull. So that negative charge, like dissolves like, helps it dissolve well in a polar solution. Alright, names of carbohydrates end in OSE. Moving on, here's our first type, monosaccharide. So mono, 1 ring. It's often in a chain or in 1 single ring. Great for an energy source because this is what goes directly into the process of respiration. So it goes directly into the process. It is the correct substrate to begin the process. There are some that you should really know the names of. 5 carbon sugars. Pent means 5. Os means it's a sugar. 2 examples of that. Ribose is the sugar in RNA. Deoxyribose is the sugar in DNA. A 6 carbon sugar would be a hexose because 6 is hex. And you should know glucose and fructose. Fructose is fruit sugar. That's like what's in oranges. And next I wrote draw a glucose. We are going to draw a molecule together. So I know that I eventually want to be able to check my numbers and make sure that I had 6 carbons, 12 hydrogens, and 6 oxygens. We start off over here like this. So I'm going to make this 6 structured molecule. I want oxygen right here. This is my first carbon. So I'm going to number it carbon 1. And then carbon 2, carbon 3, carbon 4, carbon 5. The 6th carbon is actually a branch that comes out from the ring. So this is how you count carbons. You look for the branch, look for the oxygen, and go clockwise away from the branch. So carbon 1, 2, 3, 4, 5, 6. Every carbon gets its own oxygen. So I'm going to give this one an OH group right here. Give this one an OH group. I'm going to make this one go to the center. They could really flip-flop and go either way. This one here. This one already has, this O was originally when it was in a chain, that was its O, so this carbon already has it. And I'll put one right here. If we check so far, we have 1, 2, 3, 4, 5, 6 carbons. We definitely don't have 12 H's yet. We have 1, 2, 3, 4, 5, 6 O's. So the only thing we have left are H's, and every carbon needs 4 bonds total. So we go to this carbon, 1, 2, 3 bonds already, we'll give it an H. 1, 2, 3 bonds already, we'll give it an H. 1, 2, 3 already, 1, 2, 3 already, 1, 2, 3, this one needs an H, and this one needs 2. Now I should be able to go through and count H's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Awesome. That's how you draw glucose. On to disaccharides. So di means 2, saccharides means sugars. So these are 2 rings. They are also an energy source because all you have to do is break the 1 bond that connects the 2 monosaccharides. We call that hydrolysis. So hydrolyze means to break the bond. And they are formed by dehydration synthesis. I'm going to show you a picture. We're going to draw it in a minute. But dehydration synthesis is when you take an OH off of one and an H off the other and you allow them to connect. When they connect through that oxygen, we call it a glycosidic linkage. We're going to notice the number of the carbons that are linked, and we could call it a 1,4 glycosidic linkage or a 1,6 glycosidic linkage. Some examples: sucrose, maltose, and lactose. Sucrose is what you get if you connect a glucose and a fructose. Maltose is a glucose plus a glucose. And lactose, I include in there because some people are allergic to it, glucose plus galactose. So those are 3 different monosaccharide examples. All right, if I draw a picture, here is my O, carbon 1, 2, 3, 4, 5, 6. I didn't draw them all in because I'm trying to make it look a little bit simpler. I'm going to do the same thing over here. Carbon 1, 2, 3, 4, 5, 6. So this was my carbon 4, just so I remember, and this was my carbon 1. This carbon 4 also has an OH group, and there would be an H coming off of here and an H coming off of here. All right, dehydration synthesis means I'm going to remove water, and in order to have these two join at all, I need to break bonds to form bonds. So I'm going to take an H off of that hydroxide group, and I'm going to take the entire hydroxide group off here. That's my removal of water. That's my dehydration. Synthesis means I got to put together and build something larger. This oxygen always needs 2 bonds, so this oxygen will form its bond with this carbon, which is now missing one of its 4 bonds. In the end, it looks like this. Here was my O, here was my 1 carbon, 2, 3, 4, 5, 6. It now has an O in the middle, so this was carbon 1, this is carbon 4, 5, 6, over to the O, down to the 1, like that. So this connection between the 2, that is my glycosidic linkage. So I'm just going to draw a circle right here. The connection, the new forming, there it is, glycosidic linkage. We got it because we removed water. So we started with monosaccharide, monosaccharide. We ended with a disaccharide, and we ended with water. So if we also look at our formula, C6H12, oh, that looks ugly. C6H12O6 plus C6H12O6. It seems like we would have C12H24O12, but you have to subtract out the water. So minus H2O. My disaccharide will have the formula C12H22O11. So remember in the beginning how I said it's almost 1 to 2 to 1 every time? That's almost 1 to 2 to 1. The reason why it isn't perfect is because you have to remove the water when you connect the 2. All right, last grouping of carbohydrates are the polysaccharides. So the big long chains, macromolecules. So in order to form them, you have a lot of dehydration synthesis, and lots of times they end up insoluble. They don't dissolve in water anymore once you have the long chain. There are 4 types that I want you to know. The first one is starch, because you eat it. Plants make starch. So it's used to store energy, lots of linked glucose, and they usually have no branches. No branches means easier to digest, which is why we can eat foods that are starch so well. Cellulose. We can't digest it very well because it does have some branches, and it's a very fibrous molecule. It makes up plant cell walls. So plant cell walls have a lot of fiber, a lot of cellulose in them. All right, chitin. Chitin is another carbohydrate, but it has nitrogen in it, which makes it very strong, which makes it great for an exoskeleton of an arthropod. And last one, glycogen. That is our storage molecule. We can't make starch. We don't have the enzymes for it. But we can make glycogen. So when your blood sugar levels go too high, your liver will produce glycogen. It'll take the glucose, do dehydration synthesis, put them together and form this molecule. That way, when your blood sugar level goes low, you can turn glycogen back into glucose.
Yeah.